Welcome, everyone. Have you ever spent hours searching multiple job portals, opening dozens of tabs, filtering results, and still wondering whether you found the right opportunity? Now, imagine having an AI assistant that performs all of that work for you automatically. Welcome to AIQE Academy, Enterprise AI Case Study Series, episode number 2. What makes this academy unique is its focus on solving real business problems and everyday challenges using practical, hands on AI solutions. Every case study is accompanied by complete source code, enabling learners to understand, build, and extend the solution themselves. Hi, I'm Anthony Prabhu. With over 20 years of experience in quality engineering and enterprise delivery, worked with some of the leading organizations such as Accenture, Polaris, and Qualitest. I'll show you how to build practical AI solutions that engineering leaders, architects, and QA professionals can apply in the real world. In this case study, we're going to build an AI powered job search engine using enterprise grade AI engineering techniques. This is not just another chatbot, it is an intelligent AI workflow that can understand your career preferences, search multiple sources, evaluate job opportunities, and present only the most relevant openings. Throughout this project, we'll combine the power of LangChain for orchestration, OpenAI for reasoning, Selenium for intelligent web automation, Langsmith for observability and debugging, and Google Sheets for storing and managing the collected job information. More importantly, this project demonstrates how multiple AI components can work together as a production-ready enterprise solution rather than as isolated scripts. By the end of this case study, you'll understand how to architect an end-to-end AI application that integrates large language models, browser automation, external tools, and enterprise monitoring into a single intelligent system. Whether you're an AI engineer, solution architect, quality engineering professional, or someone preparing for the next generation of enterprise AI applications, this project will provide practical experience that you can immediately apply in real-world scenarios. So, let's begin our journey and build an AI powered job search engine from the ground up. Yahoo! Let us get started. It is a perfect Saturday morning, and you wake up with a cup of coffee and decide that today is the day you are going to seriously look for your next career opportunity. You open LinkedIn and type QA Architect. Then you think, maybe companies are using a different title. So you search for Test Architect, then Quality Engineering Manager, then AI Solution Architect. Suddenly, one search has turned into 15 different job title variations. Now you realize you're only searching in San Francisco. What about San Jose? What about Sunnyvale? What about remote positions? Now you've repeated those same searches across 15 different locations. Then someone tells you, don't just use LinkedIn, check Indeed as well. So you do it all over again. Within 30 minutes, you're staring at thousands of job postings. Many are duplicates, some are completely unrelated. The challenge isn't that there aren't enough jobs. The challenge is that there's far too much information and very little intelligence helping you find what truly matters. This is exactly the kind of problem artificial intelligence was built to solve. Instead of asking people to manually search, compare, remove duplicates, remember previously seen jobs, and decide what's relevant, we can delegate those repetitive tasks to a team of AI agents. That simple idea became the inspiration for the multi-agent architecture you'll see throughout this case study. An intelligent system designed to do the heavy lifting, so professionals can spend their time making better career decisions instead of performing repetitive manual work. Given the situation, we have 4 core challenges. The first is duplicate listings. The same job often appears across multiple portals, forcing candidates to review identical opportunities several times. The second challenge is manual filtering. Every job description has to be read and evaluated individually because there is no intelligence helping prioritize the results. The third challenge is the time drain. What should take minutes often consumes hours every single day. Finally, there's poor relevance. Search results are based on keywords rather than true understanding. So, highly relevant opportunities are buried among hundreds of unrelated postings. Our AI solution is designed to eliminate each of these pain points through automation and intelligent decision making. What we've discussed so far naturally leads us to the solution architecture. Instead of asking a single AI model to perform every task, we divide the responsibility across multiple specialized stages, with each stage focused on one specific job. The workflow begins by collecting job postings from platforms like LinkedIn and Indeed. Those raw results are then passed to the first AI agent, whose responsibility is to analyze each posting, understand the job description, and assign a relevant score based on the candidate's target profile. Next, a second AI agent independently reviews those recommendations. Rather than trusting a single opinion, we introduce a second layer of AI validation to improve confidence and reduce incorrect selections. After validation, the approved jobs are compared against persistent memory to identify postings that have already been processed, ensuring that only genuinely new opportunities move forward. Finally, the results are automatically formatted and delivered into Google Sheets, creating a clean, structured dashboard that is always up to date. The entire process runs end to end without manual intervention, transforming what was once hours of repetitive work into an intelligent, automated workflow. One of the biggest misconceptions in AI today is assuming that an AI agent is simply another name for a large language model. In reality, they are designed for very different purposes. As you can see on the left, a traditional LLM follows a straightforward pattern. You provide a single prompt, it generates a single response, and the interaction ends there. It doesn't remember previous tasks, it doesn't use external tools on its own, and it doesn't make autonomous decisions. It's excellent for answering questions, but it's fundamentally stateless. Now look at the AI agent on the right. Instead of responding to just one prompt, it's driven by a goal. To achieve that goal, it can reason across multiple steps, invoke external tools such as web browsers or APIs, make decisions based on intermediate results, and maintain persistent memory between executions. Finally, it produces structured, machine-readable output that can be consumed by own stream systems. That's exactly why an AI agent is the right choice for this case study. Finding the best jobs isn't a single question, it's a multi-step business process involving search, filtering, validation, memory, and delivery. An AI agent orchestrates all of these activities automatically, making it far more suitable for enterprise-grade automation than a traditional LLM alone. LangChain is much more than a library for calling an LLM. You can think of it as the orchestration layer that sits between your application and the language model, coordinating everything required to build a production-ready AI system. The diagram on the left illustrates this layered architecture. At the center is the core prompt, which captures the business objective and tells the AI exactly what we want it to accomplish. Surrounding that is the orchestration layer, where LangChain manages the execution flow. It maintains context, coordinates agents, invokes tools, handles memory, and ensures that every step in the workflow happens in the correct sequence. The outer layer represents the interaction with the LLM itself. Once the reasoning is complete, the response is converted into structured output using pedantic schemas, making it predictable and easy for downstream systems to consume. Another major advantage is observability. LangChain integrates seamlessly with LangSmith, allowing us to trace every execution, inspect prompts and responses, measure latency, monitor token usage, and quickly debug failures. These capabilities are essential when deploying AI applications into production. In short, while the LLM provides intelligence, LangChain provides orchestration. It transforms isolated model calls into reliable, scalable, and maintainable enterprise AI workflows, which is exactly what our multi-agent job search solution requires. Now that we've explored each individual component, let us bring the entire puzzle together on a blackboard and walk through the complete end-to-end architecture of our AI-powered job search system. The workflow begins with the configuration layer where we define the job titles, preferred locations, search filters, and any exclusion rules. This allows the entire application to be driven by configuration rather than hard-coded values. From a coding perspective, entire configuration layer is embedded in the Python code. Next, Selenium automates the browser to search job portals such as LinkedIn and Indeed, collecting the latest job postings. These raw results are then consolidated into a single dataset. Before involving AI, the system performs deterministic deduplication using Python. By removing duplicate listings early, we reduce processing time, lower LLM costs, and ensure that each job is evaluated only once. The filtered dataset is then passed to Agent 1, whose responsibility is to score every job based on its relevance to the target role. Rather than simply matching keywords, the agent uses reasoning to understand how well the job aligns with the candidate's profile. The shortlisted jobs are then independently reviewed by Agent 2. Acting as a second layer of quality control, this agent validates Agent 1's decisions, helping reduce false positives and improving overall accuracy. Once approved, the jobs are checked against persistent memory. Previously processed jobs are identified and removed so that users only receive genuinely new opportunities each time the workflow runs. Finally, the output agent formats the approved jobs into a structured schema and publishes them directly to Google Sheets through the Google Sheets API, giving users a live dashboard that is clean, searchable, and immediately ready for action. This end-to-end pipeline demonstrates how browser automation, deterministic processing, multiple AI agents, persistent memory, and cloud integration work together to deliver a scalable, production-ready enterprise AI solution. Building an AI application isn't just about getting the right answer. It's about delivering reliable results every time. Every AI response is validated using Pydantic schemas to guarantee the expected structure. And structured outputs ensure that downstream components receive clean, type-safe data. These engineering practices transform a prototype into a resilient, enterprise-grade AI system that can operate reliably in production. Let's take a quick look at the technology stack behind this solution. Python serves as the foundation, providing the core application logic and automation capabilities. LangChain orchestrates the AI workflow by managing prompts, chains, and interactions with the language model. OpenAI powers the reasoning engine that evaluates and scores each job posting. LangSmith provides end-to-end observability, allowing us to trace executions, monitor performance, and debug AI behavior with confidence. Selenium automates browser interactions to search job portals and collect listings in real time. Finally, Google Sheets acts as the reporting layer, delivering structured job recommendations in a format that's easy to review and share. Together, these technologies create a modern, scalable, and enterprise-ready AI application. Simply configure the required skills and preferred job locations in the Python script. The multi-agent automation framework takes care of the rest, collecting relevant job postings and delivering the final results in a neatly organized Google Sheet. All you need is to just click on the link and post your resume. Is it not exciting? Let's conclude by summarizing the key takeaways from this case study. First, using multiple AI agents provides higher quality results than relying on a single agent. Second, LangChain gives us enterprise-grade orchestration, making it easier to manage prompts, workflows, and observability through LangSmith. Persistent memory enables the system to learn from previous executions and avoid duplicate work. The architecture we've built is reusable and can be adapted to many business problems beyond job searching. You'll find the GitHub repository, complete source code, architecture diagrams, datasets, and presentation PDF in the video description below. If you're passionate about enterprise AI and the future of quality engineering, subscribe to AIQE Academy. Every week, we'll explore real-world AI case studies, production-ready code, practical architectures, and lessons learned from building intelligent enterprise solutions. Thanks for watching, and I'll see you in case study number 3. Bye-bye. Take care. Have a wonderful week ahead. This is Prabhu signing off.